Hi, good afternoon, everyone. We're just about to start. I'd like to thank you all for joining. And before we begin, I'd like to just note some webinar house rules. Please firstly note that this meeting is being recorded and it will be made available online afterwards. I would kindly ask that everyone remains muted unless speaking when invited by the chair, and that we do not use our cameras so as to keep a clear line. Thank you for using the chat function to raise your questions, and we will pick those out according to the time that we have available to us. But any questions we do not get around to, we encourage you to, of course, share those with us also by email, and we will come back to you on those later. With that, I'd like to pass the floor to my colleague, Mika Hack, BSEF Secretary General. Thank you.
Thank you very much, Patrick. Yes, and welcome. Good morning and good afternoon to all of you here.
And here, Mikael.
To this hybrid meeting. We are BSEF. We are the Global Association of Bromine Producers with Albemarle, Lanxess, ICL, Toso, and Haiwang as our member companies, which are also present on this call. We are headquartered in Brussels in the EU, the lighthouse of chemical regulations here globally. And we have representatives and footprint in Japan, in Korea, in Australia, China, India, Vietnam, as well as in the Americas. Why are we there? We are there because electronics are produced there. And we are a fundamental part here of this. Our formulated flame retardants serve for fire safety and help producers to meet fire standards. We have today a very important topic here when it comes to recyclability. And with that, I hand over to Bob Miller, Vice President at Albemarle and the Chairman of the BSEF.
Great, thank you, Michael, and welcome to everyone who's taken the time to join us today. You know, in 2020, BSEF commissioned SOFIs to generate the first groundbreaking study trying to close the gaps in our understanding of how, where, and when electrical and electronic waste is recycled. We are quite proud of this study, which has already served as an important reference in the recycling world. Recycling and our understanding of it is an important element to drive towards a circular economy where there are clear advantages of BFRs for recycling. Most recently, BSEF commissioned DSS Plus to conduct a significant update of that original report, and we are looking forward to continuing the growth of our understanding and hope that this study will be just as impactful. So without further delay, I'm pleased to introduce Arthur Harmon with DSS Plus, who will take us through this landmark study.
Thank you, Michael. Thank you, Bob. So, Patrick, can I just move the slides directly on the Teams?
You should be able to.
Okay, so can everyone see the title page?
Yes.
Yes.
Okay, great. Yeah, hi everyone. Thanks a lot for joining this this event where we are launching this new study. The study was actually published a few days ago, but today we will present some of the main findings of this study. So I hope you will learn a lot, and I look forward to the discussions and questions and answer after the presentation. For those of you that haven't had a look yet, you can have a look at the study, the report online. It's available on both DSS Plus and BSEF websites. If you scan this code, you will have the direct access. It's about, I think, 80 pages, 90 pages. So it's a lot of text, a lot of information. Today we won't have time to go over all of the findings, but yeah, if you have any questions, any remark, comment, please reach out to us in the Q&A or after the call, after the presentation. So as mentioned previously, this this work that we have now completed is basically an update of a study that we did in 2020. Back then we were still called Sophies, and now we are part of DSS Plus, but it's still the same team behind it. This study was looking at the impact of brominated flame retardants on the recycling of plastics from WEEE, also called e-waste, so waste
Sorry,
electrical and electronic equipment.
We still see the first slide with BSEF seminar. So probably, I don't know, Patrick, if someone need to move
then
slide.
sorry.
Oh, now, yes.
Okay.
Now we see them.
Does it work now? No. Because every time I have to click on sync to the presenter. That's not. Patrick, is there a way to make me the main presenter?
You just have to share.
Sorry, Patrick.
If you could share your screen, it would be possible.
Yeah, okay. Yeah. Because actually on my screen I can move through the slides, but on Teams. But I will then share my screen. Okay. So sorry about that. So does it work now?
Yes. Perfect.
Okay, sorry. So, well, that's the QR code if you want to access the full study. But as said, you will find the links also on LinkedIn, on the web pages of BSEF and DSS Plus. So, yeah, as I was saying, this is an update to the previous study. The main objectives of the update were to present updated data on the composition of WEEE plastics, focusing on BFR trends, so levels of BFRs and how they evolve over time, and also looking at data, up-to-date data on the fate of WEEE plastics in Europe. So as in the first study, we focus on Europe, even though for this update, we also looked at the status and the fate of WEEE plastics in Japan. We also wanted to review the main regulatory developments related to the handling of WEEE plastics that contain BFRs, related to the POP regulations, for instance, the waste shipment regulations, and other pieces of the regulatory framework, and understand the impacts and the challenges of these developments. We wanted to evaluate the potential of emerging recycling technologies to handle the hard-to-recycle fraction from WEEE plastics. So conventional WEEE plastics recycling technologies can very well sort and recycle about half of the material which is received. For the other half, so the hard-to-recycle fraction, other types of technologies show interesting potential. We looked at solvent-based recycling and pyrolysis, and also at depolymerization as types of technologies. We also finally wanted to evaluate and identify challenges and opportunities for the incorporation of recycled plastics into new EEE. So looking at the closed loop recycling of plastics from WEEE into new electronic appliances, seeing the current trends, the current commitments of manufacturers, but also the challenges faced by manufacturers as well as by recyclers. Finally, all in all, this study provides a comprehensive overview on the current state of WEEE plastics recycling, identify opportunities for improvement, and also develop a wide range of recommendations for different types of stakeholders. Due to, for just sake of time and to also not overwhelm you with information, we decided to focus on two aspects in this presentation. So the first, looking at basically the data, what the data says in terms of levels of BFRs, as well as in terms of fate of WEEE plastics. and also discussing some very important but also challenging regulatory developments in Europe. So I will now go over some of these main findings related to these 2 points. So first, looking at the big picture, we wanted to create a realistic or as accurate as possible and as complete as possible picture on the flows of plastics from WEEE in Europe. We already had such a picture in the previous study. Now we have updated it and also added some level of detail to it. So what you can see on the left is the amount of WEEE plastics which are being generated each year in Europe. So it's currently about 2.6 million tons. So it's a lot of waste plastics. And a bit more than half of that is actually entering the official separate WEEE collection. So through WEEE collection points, these plastics, which are still part of the equipment, get collected separately. And these materials are then sent to WEEE processing operations. So dismantling center, shredding centers, which separate the different components and the different material fractions found in WEEE to then send it further downstream to either recycling or disposal installations. When it comes to WEEE plastics, so as said, it's a bit more than half. It's about 54%, which is actually separately collected. That's the WEEE, the separate collection for WEEE in Europe. Plastics are then separated at this stage. But according to the data which is available, quite little of that is actually then sent to specialized formal WEEE plastics recycling facilities in Europe. These facilities apply different sorting and recycling technologies. All in all, they can recycle about half of the content of the input into plastic granulates, which are then used to make new products. And the rest is sent for disposal, mainly through incineration, but also in some cases, in some jurisdictions, also landfilling. The big chunk here is the mass balance, the difference between these two flows. We don't know what this is going to. Now it's going all into this unknown category of whereabouts. It can be different things. It can be directly sent for incineration, for instance. It can be exported for recycling abroad. It can be that this estimate is an underestimate and that more are reaching the specialized facilities for recycling in Europe. So it can have different reasons. Basically, looking at data currently available, that's we don't know more about this flow. Looking at other arrows here, so this is basically WEEE, so e-waste, which is not separately collected. So we know quite a lot is treated as scrap metal, so recycled for its metal content, and we don't know what happens to the plastic fractions. Quite a lot of WEEE is ending up in the waste bin, so the small WEEE, which you can put in your household bin. That's a lot of material. It's about 200,000 tons in terms of plastics. And this is sent then to incineration or landfilling, depending again on the cases and the jurisdictions. And then you have export of WEEE or used EEE for reuse, which can be legal if, it's actually not a waste and it's tested and it's fit for reuse. So this is happening and this is partly documented. And also there, of course, the plastic fractions also get exported with it. You have illegal exports and also you have the remaining the mass balance, which is unknown whereabouts. So overall, looking at this picture, it's quite a grim picture. Yeah, most WEEE plastics actually escape or don't reach the right places, which would be the WEEE plastics recycling in Europe, or at least maybe not the right, but at least we know very well what is happening here. We just don't know what is happening here. So there is a lot of plastics from WEEE which have unknown fate that go through undocumented channels. And there you have a high risk that the plastics that require specific care, such as those containing legacy additives, such as PBDs, do not get handled in a proper way according to international regulations and standards, because it's just not controlled. It's not controllable, and it's not documented. But this share, so the share of WEEE which is being collected is rising every year, slowly but surely. It's being increased. So yeah, it's going into the right direction, but still a lot of even downstream, a lot of fate is unknown. Now, going from the big picture, from the macro level to the detailed micro level, here what you see is an average or a synthetic picture of the average level of BFR containing plastics in WEEE. So electronics, WEEE waste electronics contain about 25% of plastics. In these plastics, about 96.5% are free of BFRs. You don't find BFRs in the 3.5% of WEEE plastics that do contain BFRs. Only a very small fraction contains restricted BFRs. Under restricted BFRs, we include PBDs, PBBs, and HBCD, which are the three classes of POP BFRs. Even though in reality, what you find in WEEE is mainly PBDs, PBBs, and HBCD it's rarely found in WEEE. So overall, only 0.2% of plastics from WEEE contain restricted BFRs nowadays, on average, meaning across all categories of WEEE, across all categories. So I'm hearing an echo. In some categories, you find higher share of both BFRs in overall, and also higher share of restricted BFRs. We will see that in the next slide, but this is here really a weighted average across all categories. Now, looking at more detail, you can see on the right here the graph is showing levels of BFRs, so total bromine content, which is the top of the bar, and specifically also PBD content, which is the orange part of the bar. We show PBDs because, as I said previously, that's the only relevant restricted POP BFR in WEEE plastics, which you still find nowadays in samples. So here you see per category and per year, you see the number of samples which we have in our data set. For instance, here for temperature exchange equipment, we have data on BFR levels from 12 samples collected in 2010 and 15 samples collected in 2017. You can see for other types of equipment or other categories of WEEE and other years, we have much less samples. In some cases, we only have one sample for 1 year. These types of data are difficult to find. They are not. There is a few organizations which do collect such data, but often are not willing to share that data. but luckily we were able to get access to some of that data, either through published resource or published sources, or also through direct sharing of the data with the project team. So you have the number of samples, the total bromine level, and PBD levels, and per category. So you have temperature exchange equipment, large non-cooling equipment, small equipment, and screens. In screens, you can have samples of CRT plastics only, some samples of flat panel display plastics only, and some mixed samples of screen plastics. So overall, we have 138 samples in this data set, and this is only samples of unsorted WEEE plastics. So before any sorting, before any processing, this is really the raw mix which is arriving at WEEE plastics recycling facilities. And this is interesting because it informs us on the levels in the mix, in the waste mix, before any sorting can be done. Looking at trends, it's not obvious, but we do see a decline in BFR levels in plastics from screens generally over time, both in the total BFR level, but also in the specific PBD level. So for screens, we do see a decline. For small equipment and large equipment, it's less clear. It seems to be a bit more stable, at least in terms of total BFR level. But we do also see a gradual decline in the share of PBDs in these categories. Still, looking at recent samples, so since 2020, we do find still high levels of PBDs in individual samples. So up to, for instance, more than 2,000 ppm of PBDs in plastics from screens, and more than 600 ppm in plastics from small appliances. At the same time, we also have a lot of samples from recent years where PBDs were not found above the detection or quantification limit. So we see both. We see individual samples with high levels and samples with no measurable levels. Across the samples, on average, we have about 200 ppm of PBDs in plastic from small appliances nowadays, and 800 ppm in plastics from screens, again nowadays. So that gives an idea of the raw, of the levels of PBDs in the raw mix. Basically, the level at which the low PAP content applies according to the PAP regulation. And that's, I think, the third and last slide on levels of BFRs in the unsorted mix. It's a bit complex chart, so it's a box plot. I have put here a legend to make sense of the different shapes and forms that you see in the chart. So you see the average levels, which is at X, the line, which is the median. You see the first and third quartiles, and the minimum and maximum values. Now what you see here, it's in percentage, and that's actually the share of the total bromine content which you can attribute to PBDs. So basically, if you take one sample and you analyze both total bromine and also individual PBDs, you can compare both values and you can explain X% of the bromine content by the presence of PBDs. If you see, let's say, 100 ppm of bromine and 30 ppm of PBDs, then more or less you can say that 30% of the bromine content can be explained by the presence of PBDs. It's an interesting parameter, or an interesting indicator on the level at which PBDs still represent a significant contributor to the total bromine content. because bromine is used as a tracer, as a proxy for the presence of PBDs. So it's good to know if it's at which what is this share. So a few years ago, around around 2015, 2016, more than 20% of the total bromine content could be linked directly to the presence of PBDs. And nowadays, it's below 10%. So we do see a decline in these levels. We do see that less and less of the bromine content can be explained by the presence of PBDs, which basically means that the PBD levels are declining in the waste streams, in the wee plastic streams, which show that the restrictions put in place 15 years ago are basically working. Maybe not as fast as expected or as wished, because products do stay in use for long times. But overall, the trend is quite clear that we do see this decline in the levels of PBDs. This could be used as an argument to say that this 2000 ppm bromine content, which is used by the Senelec standard, could be actually increased in theory, even with the new low-pop limit values. We show that in the report. We could actually increase that safe limit, but in reality, there is also not practical need to do it. It's a threshold which works really well, which is well accepted and well achievable. So we think it can be kept, and it's basically just a very safe threshold, even more safe than when it was set a few years ago. Now, this is so the previous slides were showing BFR levels in the unsorted mixture. Now we look here at the BFR levels in the sorted plastics after separation of BFRs. So this is the low BFR fraction, which is then transformed into products, into pellets. And we have also data on this on this level of the value chain. On the charts, you see on the left side the PBD levels, and on the right side the overall or the total bromine level. We have such data for small equipment, so plastics from small equipment, as well as from screens. Interestingly, here in this low bromine plastics fractions, you still find up to almost 2000 ppm of bromine in screens, and a bit up to 2,400 ppm in small equipment. And you also find up to about 500 ppm of PBDEs in plastics from screen and small equipment in recent samples. And sometimes the laboratories, so the professional labs which operate according to standards, report quantification limits up to 400 ppm. This is the orange values that you see. There is one sample for which this quantification limit is 400 ppm. It's quite high. In many cases, it's lower. It's between 150 and 200 ppm as reported quantification limit by the lab. Looking at this data, we can say that the UTC levels proposed by the Commission are, the 500 ppm threshold is challenging. It's basically the limit of what can be nowadays achieved for plastics from screens and small appliances. So it can be met, but it's really at the limit of what can be nowadays met. 350 is already problematic. It cannot be reached in all cases. Actually, quite a large share of the samples that we have in our data set, it is not reached, or it's very close to being not reached. So that could mean that many plastic granulates will not meet the regulatory requirements. And 200 ppm is basically cannot be verified in many cases. So in many cases, you have quantification limits reported by the labs of from 200 ppm up to 400 ppm. So that means you cannot actually verify that your levels are below the UTC level if this level is 200 ppm. So that's the main challenge. Yeah, so I mentioned these LPC and UTC limits. So these are terms coming from the European BOP regulation, which have been revised in the previous years regarding PBDEs and HBCD. So for waste levels, I mean, yeah, for the limit in wastes, this is the low PAP content limit, which was decreased from 1,000 to 500 ppm for HBCD starting in June this year. And there is a potential further reduction to 200 ppm starting in December 27. For PBDEs as well, this LPCL limit has been decreased from 1,000 ppm to 500 ppm in June this year. So the currently applicable limit is 500 ppm. And there is a possibility to further decrease these levels to 350 ppm by 27 and ultimately 200 ppm after 27. Unless the UTC value is higher. So the UTC value is also has to be set. The challenges there are the lack of reliable and demonstrated sampling and analytical standards to measure these chemicals in concentrations below 1,000 ppm in mixed wheat plastics. So that's the main challenge. For the POP limits in products, so that's the UTC level. Currently for HBCD, it's 100 ppm, and it will be reduced to 75 ppm, except for building and construction materials. For PBDEs, the current level is 500 ppm, and there is an ongoing process to lower it to 350 ppm and then 200 ppm later down the line. So as shown in the previous slide, this decline, these 350 and 200 ppm potential UTC limits are very problematic, if not impossible to reach, because impossible to reliably measure. So all of this is causing concerns within the recycling industry of increased costs and also increased difficulties to access waste and also to recycle products. So some conclusions, some key takeaways from our study is that, well, first, as we saw, thanks to the historical restrictions, the levels of restricted BFRs have been declining in wheat plastic streams. So the regulation is working. It takes time, but it is working. But the time it takes should also be considered when further reducing the threshold. Another good news is that specialized wheat plastic recycling facilities are very well able to remove the BFR containing fractions. They can remove more than 95% of the BFRs in wheat plastics, even though it's not 100%. So you still have some residual BFR levels in the granulates in the products, which, looking at PBDs, we saw was, yeah, for screens and small appliances at around 500 up to 500 ppm. Some not so good news, not so good findings. So most wheat plastics escape formal collection, escape proper management through undocumented, unregulated channels. So if one is concerned about potential leakages of, for instance, PBDEs into the environment, well, this is a major bad news. Because there is a high risk that these plastics are not properly managed in these unregulated channels. And another negative development is that the current regulatory developments, which we just discussed, I mean, we looked at the POP regulation in the previous slide. There's other developments in the waste shipment regulations, which also negatively impact the proper management of WE plastics in Europe. So it basically makes the life of European WE plastic recyclers harder. It makes it harder to access waste, harder to recycle waste, and harder to also sell the products. So this calls for a wide range of actions by different stakeholders. So in the study, we developed different recommendations. Here are the main ones. So for policymakers, we strongly recommend to really work on adapting the framework conditions to ultimately facilitate the channeling of WE plastics inside closed, certified, and controlled loops, industrial loops, to really have a proof safe, I mean a leak-proof system to collect and transfer and recycle or dispose these plastics, and to really make it easy for plastics to channel through these loops and hard to escape, which is not always the case nowadays. Also, there is a need to develop sampling and testing standards to improve the accuracy and reliability of sample collection and analysis, and also to publish and communicate on data, basically establish data collection and communication platform to really be able to follow the trends in terms of composition of WE plastics and levels of legacy additives. For recyclers, we recommend to keep developing, piloting, and investing in innovative technologies to recover more value from the waste fraction from these hard-to-recycle plastics, and keep establishing and pushing for partnerships with producers to help or to work on solutions to design for recycling, but also from recycling. So looking at designing products with the use of recycled plastics in mind. Producers should adopt and also stick to ambitious recycled content targets. This is really the key lever to promote the recycling industry, to have these recycled content targets in place, ideally being closed loop targets. So an electronics OEM should ideally aim for X% of recycled content from electronics plastics, and work again on this idea of design for and from recycling. So that was an excerpt of this study. In the full report, we go through many different other subjects. So I again invite you to have a look at the executive summary and the full report, and happy to answer any questions at any point in time, also after the event. So thanks a lot for the attention, and I think now we have still some time for Q&A.
Great. Thank you, Arthur, for this good overview of the study. Indeed, we have received one comment which has come in from Paolo Campanella. Does data in the flowchart refer only to WE plastics, or are they mixed between total WE and WE plastics? And I think this is in reference to slide 6 or 7 you were on at the time.
Yeah, let me again share the screen. So the quantities are only referring to WE plastics.
Okay, thank you. Are there any other questions? It's very clear, clearly. In that case, if there's no other questions, then may I ask Sander, our recycling chair, and Chair of the Advocacy Working Group and Director of Advocacy Europe for ICL, say some closing remarks. Thank you.
Yeah, thank you, Patrick, and thank you all participants for joining this seminar today. Special thanks to Arthur for presenting this comprehensive study in only a few slides, which is quite a difficult task, I'm sure. And thank you also all the DSS Plus people, of course, who contributed to this extraordinary piece of work. And I think this information, this extensive amount of information, will, of course, and hopefully contribute to an informed decision-making by the regulators in the near future, which should always be based on facts rather than assumptions. It was already said, the report itself is available online, both from the DSS side as well as the BSEF side. The recording will become available in a couple of days, including the slides which were presented today. And any additional questions you might have after reading the report, please send a message to BSEF or DSS Plus people. They will answer them wherever they can. And again, finally, thank you all again for participating, and I wish you an enjoyable work week.
Many thanks. Thank you, everyone.